Hey, what's up, guys? This is Chung. So today, LeetCode 966, Vowel Spellchecker. You're given like a word list, and we want to implement a spell checker that converts the query word into a correct word. And the rules are like kind of long here. So, but to summarize it real quick, given like a query word, we need to do basically three checks. So I'll scroll down here. So here is the priority, the priority of each of the rules here. So whenever we have like a query that matches exactly the word in the word list, so so the first one is case sensitive. So of course we will return the same word back. So this is the first priority. And second one is the if this one doesn't match, and then we go to check the second one, which means that we check if there's any word that can give us like a case insensitive match, right? So we can either convert it into a capitalization, uppercase or lowercase. But the second rule is that if there's like a word matches the current one, the query, uh, in the uh, with a case insensitive manner, then we return the original word for that. And the third one is the if the query matches a word to a vowel arrows, we should return that first one. So what does this one mean? So this one means the if you can replace all the if you can replace all the vowel letters a e i o u to a different vowel numbers, and then the new word will match the original word, the original word in a case insensitive manner. We that's also a match. Then we'll also return the that original word. For example, right? So we have a YOLLOW. So basically, this O and O they can be replaced to any of the vowel letters. So that's why we have a E here. We can replace this O with E, and then we have a case insensitive match. And here it's like the of course, the length is different. That's why there's no match. And here's also another one. And in the last one, if there's no match at all, we simply return empty string. So, I mean, to solve this kind of problem, we just need to create a bunch of helper data structures to help us to check each of the rules here. The first one, exactly match. This is easy, right? We just need to convert this word list into a word set, and we check that first. And second one is that we need to create a dictionary, and then we will basically the key for the dictionary is the key for the dictionary will be the uppercase, uppercase letters for all the letters for all the word, and the value will be the original value. Okay, and since we also need to return the first, basically the first return. If there's multiple match, right? We need to return the first letters that match this word list. So what does it mean? It means that if we have like two word, let's say we have a KITE, right? And then we have another one KITE. So those are the two different words. And if we convert them into a capitalizations, they will all be ending up with sorry, KITE. But the rules is telling us we should return the first one, which means we should return return this one, not this one. So that's why when we build this dictionary, the uppercase dictionary, we'll only be inserting this KITE with as a key, and the value is KITE. Will not insert a entry for this for the second appearance. So basically, what this one telling us that we only insert to the dictionary whenever that key does not exist in the dictionary. If it's already there, we just skip that. That's that. Okay. And the third one, the vowel case, the A-E-I-O-U case. This one is a little bit tricky, because since we can change any of the vowel letters into any of the vowel letters freely. So it means that uh, so what we can do here, we can create a mask. So which means that for this like Y-E-L-L-O-W, we can replace all these vowel letters into a wild card, which means that we have a Y star LL star W, right? And since the match is also case insensitive, we'll also, besides converting all the vowel letters into a star in the wildcard, we also gonna convert the other letters into its uppercase. So from this Y-E-I-O-W, we'll have like a Y, we have Y star L L star W. So this is gonna be the key for the second dictionary, and the value, of course, is the also the original letter, right? Original word. And since the third rule also asks us to return the first match, so which means that we're going to use the same logic as the first one. Basically, if the key is not in there, then we just insert. Otherwise, if the key is there, we simply skip that, right? So this is kind of similar. If with similar reason, let's say we have a while LW, right? This is the first word, and second one, let's say we have a like Y-I-L-L-E-W, right? So basically, these two words, they will end up with the same key with this one, and we're only gonna store the value for the first one. Yep, I think that's it. So we're just going to build those three uh, data structures to help us to verify the first all the three spell spell checks, and then in the end, if none of them works, we simply return empty string. Cool. So to start with, so we have a word. So first one is the word set, right? So this one's easy. We just convert the word list into the word set. And second one is that like the word uh, map upper. Excuse me. So this one is it's used to check the capitalization. And the third one is the word map vowels, right? So this one is gonna help us to check the vowel arrows. So let's build those two dictionaries first. So for word in word list, okay. And if the word dot upper, right? So since we're going to store the uppercase, because these two checks, they're both case insensitive, not in word map upper. And then I'll just do a word map upper dot word upper, right? Equals to the word. So that's how we build the first dictionary. And for the second one is we have to replace all the vowel letters into a star, and then we convert all the others into its uppercase. So I'm going to create a mask, right? So I call it a mask, and I convert everything into a so for this one we traverse all the each letter in this word. So basically for C in the word, right? So for this one, and we convert this one into a star. So the first case star if the C dot lowercase, right? So this is like a little bit uh, things we have to be careful, because this A-E-I-O-U, it could be in both the uppercase or lowercase, right? It could be like this. That's why I always convert this into a lowercase. If this one is in the A-E-I-O-U, okay, and I replace it with like this star. Else, I else we convert it into its uppercase, right? So that's the mask. And similarly, if the mask not in the words map vowels, right? Then we just insert it. Mask equals the word. Cool. So now we can start populating the answers, right? So first we have queries in the queries. And so we have a current. I'm just using the current to store the current answer. So in the end, I can just append this answers to the answer to the list, and then I just return the answer. That's that, right? So first we check if the query is in the word set. If it's in the word set, then that's the first rule, right? We find the exact match. That's why we're going to use this query itself. Else, um, else if the query dot upper, since we are storing the uppercase as a key in the word map upper, right? And then if the second rule is met, we just return the word from this second rules dictionary. So q dot upper, and then the last one is the third one, right? Mm, else, right? Else here we also I'm going to use the mask here since we're going to use the mask to find the match for the third one. And here we have like the query. So the only difference is query. The way we're building the mask is exactly the same. And then we check if the mask is in the word map vowel, right? If it's in that dictionary, and then we know the current one will be the word in this in the last dictionary. Yep, I think that's it. So if none of those things works, and then the current will be staying with empty string. Cool. So let's run it. Hmm. Yeah, so it works. Yeah, I mean, yeah, basically that's the idea. So I see why this one got a lot of downvotes because it has a lot of like rules and corner cases. You need to be careful, right? But other than that, I think it's just like a bunch of implementation things, right? So for the time space complexity, I think it's pretty straightforward, right? They're just like O of n, right? Because there's no nested for loop here. Just yeah, and here the word is pretty small, right? Yeah, cool. I think I'll just stop here. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.